So we're going to continue talking about how to use the graphing calculator, not just to graph, but to help us solve equations today. So we're going to start just reviewing some of the graphing basics. If I want to graph y equals x squared plus 3 in an appropriate viewing rectangle, call up my graphing calculator, and I press y equals. If there's anything in there, you want to clear it. And also, if anything along the top where it says plot 1, plot 2, plot 3, if any of those are highlighted, you want to unhighlight them because they can mess everything up. So if it's highlighted, it might look something like that. Okay. The way you unhighlight it is you just put the cursor on it and press enter, and then it's off. So make sure that those are all unhighlighted. Nope, equal signs doesn't matter. It'll automatically highlight when you type something in. All right, so now I'm going to graph y equals x squared plus 3. So in y1, I'm going to put x squared plus 3. You have the option of using the squared button or the caret 2 button. And then a good place to start, it would be zoom standard in terms of trying to find a window. So you hit zoom 6, which is just a -10 to 10, -10 to 10 window. And then we could adjust it to our preferences. We have a lot of empty space in there. So I might go to window and I might chop off some of this bottom stuff and some of this emptiness to the left and right. So you go to window, and for x min, x max, maybe I'll only go -5 to 5 because I had a lot of empty space to the left and the right. And then for y min, y max, maybe I'll only go down as far as 0. I'll just go down to the x-axis. So I'll do 0 to 10 for y min, y max. Once you have that set, you can hit graph. We have a much nicer picture of the graph. And we could continue to adjust it a little bit more, but it's all dependent on what you need the graph for. So I think that that looks pretty good. Anybody not able to get this picture?
Just the y min, y max.
0 to 10. 0 for y min, 10 for y max. Okay, so now I want to graph two things at once. I want to graph 3x squared minus 6x plus 1 and 0.23x minus 0.225. So my calculator, when I go to y equals, we actually have 10 spots for y equals. So I could graph 10 things at once, but I just want to graph the 2. So I'm going to clear what's already there. In y1, I'll put 3x squared minus 6x plus 1. And then in y2, I put the other equation, 0.23x minus 2.25. And they've given me a window in which I should look at these things. So when they give you a window like this -1 to 3, oops. -2.5 to 1.5, that's interval notation. They're giving you a range. And they always are going to go x, y. So this is x min, the 1 is x min, the 3 is x max, and the -2.5 is y min, and the 1.5 is y max. So this is how windows will generally be given to you, whether it's in your homework or on a test. If I want you to graph something in a specific window, this is what I'll tell you to do. Sure, no problem. So the question says graph these two things in this viewing rectangle. So they're always going to give you x first, then y. And this is just interval notation. It means from -1 to 3 for x, and -2.5 to 1.5 for y. So the -1 is x min, the 3 is x max, the -2.5 is y min, the 1.5 is y max. And it'll always come in that format. X min, x max by y min, y max. Oh yeah, thank you. So I have my equations typed in. I'm going to go to window and type in the window that they told me to look at. -1 to 3 for x min, x max. And for y, I'm going to do -2.5 to 1.5. So once you have the x min, x max, and y min, y max typed in, press the graph button. And it appears that those two graphs touch at about 1, -2. Take a quick picture of this. Okay, so now what I want you to do is I'm going to use ZoomBox. I showed you how to use it last class, I believe. So I'm going to use ZoomBox to put a little rectangle around that spot where it looks like they touch and blow that spot up to be the whole screen. So the way you, that's okay. Okay, so to ZoomBox, press the Zoom key, choose option 1, ZoomBox, and you see a cursor flashing on your screen. We're going to create a box around our area of interest, and I want to put that cursor in the upper left-hand corner of the box I want to make. So I'm going to put this cursor where I want to start drawing the box in the upper left-hand corner. All right, so that looks pretty good. Then press enter once it's in the upper left corner, and then you can use down and over to create a box. And this box is going to blow up to be my whole screen once I press enter again. And what do you actually see now that we've zoomed in there? They don't actually touch. Yep. Take a quick picture of this one. So the point of this example is that one, windows can be deceptive. So you have to be really careful when you're choosing a window. And that choosing windows is difficult and takes practice. Okay. Okay, so if I want to graph this circle, I have x squared plus y squared equals 9. And I'm telling you, it's a circle. So trust me over your graphing calculator when it comes up. It's a circle. It's a circle with radius 3. To graph this in my calculator, I have to solve for y. My calculator can only accept inputs that are of the form y equals some stuff with x's in it. So solve for y, and I get y squared is 9 minus x squared. So y is what? Plus or minus the square root of 9 minus x squared, which is not 3 minus x. Oops, didn't mean to do that. Right? You can't take the square root of each term separately if there's addition or subtraction. So this is not 3 minus x. So I have plus or minus 9 minus radical 9 minus x squared. So that's actually two equations. I'm going to enter that as y1 is the square root of 9 minus x squared, And y2 is the negative square root of 9 minus x squared. So go back to my calculator, go to y equals, clear what's there. And in y1, I'm going to put the square root of 9 minus x squared. And in y2, I want the negative of that, exactly the negative. So I put negative square root 9 minus x squared. Any ideas on what kind of a window you want to look at? Start with standard, sure. Zoom 6. So I've told you that this thing is a circle. Why is the calculator lying to you? Why does it look like an ellipse or an oval? Yeah, because the calculator screen is wider than it is tall. So for x min to x max and y min to y max, there's 20 units along both set of axes, negative 10 to 10. So I put 20 units in a longer space along x than I can along y. So my units end up being different sizes along x and along y. So this gets distorted. So to remove the distortion, you use the zoom square option, which is option 5 under zoom. Do zoom square. It'll automatically change your window to take out the distortion. And now it looks more like a circle. Yes. Okay. Okay, so now we're going to use the calculator to help us solve equations. So I have this equation, 3x equals 5. We can all solve this in probably half a second, right? What's the solution to 3x equals 5? 5/3. Divide both sides by 3, and you get x equals 5/3. Divide by 3, x equals 5/3. So that's 1 2/3, right? 1 2/3. All right, so this is easy to solve algebraically, but I'm going to use this easy equation to show you how to solve using 2 new methods that you're graphing with your graphing calculator. So we'll start with an easy one, move on to some harder ones once you have the method down. So method 1 is to move all terms to one side of the equation so that the other side is 0. So if I have 3x equals 5, working on step 1 here, I want to move the 5 to the other side, or move the 3x to the other side, doesn't matter. I just want one side to be 0. So I have 3x minus 5 equals 0. Then I'm going to put the non-zero expression in y1. The side of the equation that's not 0 is going to go into y1 in my calculator. Then it says I want to find the x-intercepts. My calculator can find x-intercepts. And the x-intercepts of this graph, 3x minus 5, are going to be the solutions to my equation. So we'll go to y equals, clear everything out. I'm going to graph 3x minus 5. And I'll start with a standard window, zoom 6. And the x-intercept of that graph is the solution to my equation. So the way I find it, I can get my calculator to find it for me, is through the calculate menu. It says calc right above the 4th button from the left along the top. So it's in yellow, so you press the yellow button and then calc, and you choose 0. Okay. 0 is a synonym for x-intercept. So you'll have to remember that little piece of vocab. So 0 means x-intercept. So you choose option 2, it says 0. Now your calculator is going to ask you for a few pieces of information. It needs your help to get started in finding this x-intercept. You have to give it a left bound, a right bound, and a guess. So it'll just ask you down at the bottom, it says, I need a left bound. So if you're looking right here for this point, the x-intercept, I need to put the cursor anywhere to the left of that to give a left bound. So I could, if I put my cursor right on it now, close to it. To move to the left from there, press the left arrow key. The up and down arrow keys will not move your cursor along the curve. Only left and right will work. So you move to the left, as far or as not as far as you want, just a little bit to the left. And press, what? Nope, I'm on the line. I'm going to stay on the line. And I just need my cursor to be on the line, but to the left of that x-intercept. Okay, so if I start by putting my cursor right on it, just press the left arrow key a couple of times and press enter. And then it says, now I need a right bound. So you put the cursor, on the x-intercept, press the right arrow key a couple of times and press enter. And you see what you've done is the calculator has marked the 2 spots that you put down with these little arrows. So you're telling the calculator, I'm looking for an x-intercept between these 2 spots. So you're giving the calculator a place to look, so it doesn't have to look from -infinity to infinity, right? It can't search the whole number line for a place where the graph crosses it. So you're narrowing down its search. And then it says to give it a guess. So you can put the cursor as close to the x-intercept as you want, as you can. It doesn't have to be super close, but it does have to be between the left and right bound that you gave it. So I always just put it as close as I can and press enter. And it gives me that the 0 happens at x equals 1.66666667, which as a decimal is, as a fraction, is 5/3, the solution to the equation. Yeah, it's math, enter, enter, but I don't know if you can do it from the screen. Let's see. No, you can't. But you could go to your home screen and type in 1.666666, a bunch of sixes, and then hit math, enter, enter, and it'll give you the 5/3. Yeah, very true. So the x-intercept ended up being the x-coordinate of this graph, of the x-intercept of the graph. Did everybody get that to come out on their calculator? All right, then I'll show you method 2. Same equation, 3x equals 5. This time, instead of moving everything to one side, I'm just going to leave it as it is, and I'm going to have the left side be y1 and the right side be y2. I'm going to graph both of them in the same window. And the place where those 2 lines intersect is going to be the solution to the equation. The place where they cross is the solution. So pull up the y equals screen, and I'm going to put 3x in y1 and 5 in y2. I'll start with the standard viewing window. Zoom 6. I can see where they cross, so I don't have to adjust my window at all. And then I have to figure out where those 2 lines intersect. That's going to give me the solution. The x-coordinate where they intersect will be the solution. So the way I find it is in that same menu, in the calculate menu. So you press second, trace. And this time, instead of choosing 0, you choose option 5, which is intersect. So then your calculator again needs some information. But instead of left bound, right bound guess, it's just asking you, is this the first curve? So the cursor is blinking on one of your lines. It's just saying, is this the first line that you're looking to find the intersection of? To say yes, you just press enter. Then the cursor jumps to the other line, and it's asking, is this the second curve? Is this the second line that you want to find the intersection point of? And you just press enter to say yes. And then it just asks for a guess. So you put the cursor near the intersection point and press enter. And we get x equals 1.66666666. The purpose of having to identify the curves, like the reason it asks you, is this the first curve, is this the second curve, is because your calculator actually can graph up to 10 things at once. So if you had 10 things graphed and you wanted to find the intersection of two particular ones, you have to tell the calculator which two. But it can't.
You also have to make sure you have the right, it'll say like y equals x at the top, so you have to make sure you're on the right one.
Yes, exactly. Yeah.
So how do we say no? What's wrong?
That's a great question. How do you say no? So if you do second calculate, well, let's throw in another random line into y equals, so we'll do 5x minus 4. So now I've got 3 lines graphed here. And I want to find the intersection of the same two that we did before. So you go calc, intersect, says, is this the first line? If it's not, you press the down arrow or the up arrow and it jumps lines. So you can choose the one that you want. Well, if you're finding the intersection of 2 lines, it does not matter what order you pick. And you can only ever find the intersection of 2. So when I see this solution, it's my x coordinate is the solution. What does that y equals 5 represent in terms of the equation? I know that when I solve that equation, 1 2/3 is the solution. What is the 5 all about? It's the, yes, it's y2. It's the second equation. Yeah, it's the second equation. But it's also what you get when you plug the solution into 3x. 3 times 1 2/3 gives you 5. This is the number that you would get when you take the solution and check that you got the right answer. You plug your solution into both sides and the equation will be true. It will say 5 equals 5. So that's a common mistake that people sometimes make, is not knowing which of these numbers is the solution. It's the x. Yeah. Nope, it's just the solution is just 1 2/3. X equals 1 2/3. So if we were to solve this equation algebraically, say 3x equals 5, I would divide by 3, and I would get x equals 5/3. And then someone at some point, I'm sure, when they taught you to solve an equation, they said, always go back and check. You can always tell if you got it right by plugging in your answer for x. So instead of an x here, I'm going to put a 5/3. I want to make sure that the equation is actually true. Well, 3 times 5/3, the 3's cancel and I get 5. 5 equals 5, check. The 5, this is where the 5 comes from. It's what each side of the equation equals when you plug the x in. So that's the solution. The y is just what you get on both sides of the equal sign when you plug the x value in. Okay, so I'm going to let you take some time to practice these in your groups. You have a bunch of things to solve. I'm never going to force you to use one method over the other, but for today, practice doing both of them just to get a feel of the capabilities of your calculator.